Hey everyone, I've started recording, so we should have a recording today. All right, I think we'll get started since Prashant said he's on a time limit. So welcome to CDM, everybody. We're hosting on Google Meet today since Jitsy's been a little bit unreliable with recordings. This is just temporary for this meeting as we work through recording logistics on Jitsi. So the first topic of today is an RFE for creating an audit module which persists in Rados. And here, tracker issue. I'll resend the agenda as well, because I don't think that stays in the Google Meet call. So to recap on this topic, this audit module raised by the CephFS team by Patrick, and they're interested in having Rados's opinions on including this new feature. So the idea behind it is Ceph has, we currently have an audit log which contains mostly monitor commands executed on the cluster. And this log provides an auditable history for modifications or rescue commands for the purposes of support or security. The issue is that these can be deleted, rotated, or lost. And sometimes there are some cases where we need these logs history, but they've already been deleted. So the ticket is proposing a new Rados manager or a new manager module headed by the Rados team, which accepts an audit log entry that persists for a time period. And it includes, the tracker includes some question. But the overall goal of the feature would be that I'm guessing a user would be able to, the user would be able to choose which audit logs they want to save in anticipation of needing them for an indefinite period of time. And I have, since I thought Prashant might be in this particular feature, but I'll open it up to anybody who wants to comment. And we're particularly looking for Rados feedback here.
Yeah, thanks, Laura. A little bit history around this tracker is like for one of the customer, they ran some, I think, journal recovery tool, like CephFS journal tool to recover the journal. And we couldn't be able to provide them RCA. So, and no way, like, rather like CephFS journal tool doesn't log any logs, or rather like even in any log file or something like that. So this module is to help, rather like, or log anything which CephFS journal tool, similar to that tool, you can say any tool which is rather like having any crucial information holding, like for the RCA, for the complete RCA, or rather like what really happened to kind of like any corruption, any CephFS corruption or other issues, to figure it out. Like,
what about tools that are kind of offline? Because I think the CephFS journal tool, it is necessarily online in the sense that there is a cluster running, because it's going to operate on the journal, which is stored in Rados objects. But tools such as I don't know, the object store tool or the glue store tool. Right. Do you envision those tools because the cluster would not necessarily be available, right? Or I guess that's not the right way to put it. It's more likely that it's just these tools currently don't connect to the monitors or to the cluster. They just operate on the directory or the blog device that they have passed. What about those tools? Do you envision them also log in something to this audit log, or would they still be out of the picture?
We can do that, but the problem with the Ceph object store in particular, I would say, but if you run that one in the debug, right? So it has a kind of like a default ---- debug option. It's a Boolean one, and Ceph objects tool actually uses that Boolean value to print the Boolean, like whether it's kind of like in terms of like just a C out errors, you can say, and that actually get printed on the terminal itself. We can consider that one as well, but with a Ceph objects tool, we still get like the Blue Store higher level debug logs, and it's a lot of like tons of logs, you can say, if you consider that one to merge it. We can consider that one at the level like just minimal set of logs getting logged to the audit module, not all of them.
Yeah, I'm just concerned with kind of the general, because what we want to at least partially protect against here is a user or customer running one of these tools and then not even admitting to the fact that they ran it, which even if the tool spits out some logging or debug information on stood out, if the user keeps silent about that, then we would never know. This, I think, the object store tool and the Blue Store tool and other kind of offline tools, I guess the Monstore or the Monitor DB tool is another example. These tools are, you could still, from some secondary indicators, you could still conclude that such a tool was employed, but it would be nice to, like, if we're talking about a centralized audit log, that if the cluster is available, it would be nice if those tools could also log to that log, even if it means that kind of the way they've historically been used, in the sense that they were completely local operation, they weren't actually connecting to the cluster. It would be nice to kind of think, at least consider making those tools also be be part of the picture here. I understand that it would still be, I guess, because we fundamentally want these tools to work when the cluster is completely offline, so we can't make that mandatory. But if those tools could log to this new audit log by default, I think that would be nice.
Yeah, that makes sense. Yeah. The only problem I see, like, it's in case of like if cluster is down, you can say, and someone is trying to I can think of only like the Monster tool, Monster DB tool, you can say, for the recovery of the mons. In that case, we can actually just not able to log if cluster is not accessible at all, if all the mons are down because of some Monster corruption, you can say, all of them, you can say. The other way is kind of like storing in the individual log file where that command is being run. So that's the another way I could think of, instead of like this audit log, because once you incorporate this one, the audit log module, then any tool like we are running, we need to make sure like we have minimal set of logs getting logged to the audit module, not tons of logs.
Yeah, that's why I said that this cannot be mandatory, but
mandatory.
By default, if the cluster is available, it would be nice.
Yeah.
If it was, even if it's just a single record that, okay, this tool was invoked with these parameters, right? That's already, that would be much compared to what we have today, that would be literally a ton of information.
Right.
There are a few open questions on the tracker. One of them says, what kind of permissions, Cephx key checks should there be? How should that be configured? Some of these questions that we should get further clarification from the Cephfs team. But, others are, what would the API look like? Whether all audit module entries should also be sent using the manager's Cephx credentials to the normal cluster log, and how to configure a retention specification. I'm just reading directly from the tracker for that. So if anybody has comments, you can comment on the tracker. So a broader question, do we generally agree that this feature makes sense to include?
I guess there's a general question, at least in my mind, around so tools like the ones we're talking about in the tracker and what Ilya was just talking about, right? Should we try to think about a general solution that works in both cases? Because the assumption in the Cephfs tool is that Rados in general is available, and that's why you could store something in the .manager pool. But when we talk about more intrusive offline tools like object store tool and monstro tool, that is not necessarily true. So should we have different solutions to these problems? And if at all, what other tools fall in the category of the Cephfs tool where maybe is there any tool, I'm not sure, is there any tool like at the RGW layer, for example, that could make use of the same infrastructure? Or are we just doing this for one tool is the question. Or RBD per se, yeah.
Yeah, I can answer for RBD. I think we could definitely use something like this to log stuff like, for example, when an image is forcefully promoted in RBD mirroring setting. The forceful promotion requires potentially rolling back the image to the last known good sync point, and that is from the user's perspective, this is a potentially destructive operation because it's it destroys some of the data on the image, and this is not limited to mirroring. This could be even just on a completely standalone image. If someone has a bunch of snapshots and then invokes RBD snap rollback command, that's a destructive operation. And we could definitely log that, because if someone says, well, why is my image why I can no longer mount my ext4 file system, well, that's why. So things like that, I think, and I'm sure RGW has similar cases, similar scenarios. So I think this would be useful across components. Even in the way in which it's proposed, where it relies on Rados being available and the doc manager pool being writable. And again, my suggestion for tools like the object store tool or the BlueStore tool was to just potentially change them so that if the send.conf file is available and the cluster is available, that they try to connect and try to log something. And if that doesn't work, then that's fine. So definitely not mandatory and definitely not a requirement for moving this feature forward. I don't think we need a solution that would work uniformly for both of these cases, because they're fundamentally different. One is an online manipulation and the other is an offline manipulation. It's just a general observation that most of the time when people run the object store tool, for example, on a particular OSD or set of OSDs, the cluster is generally available. And so we could capture like 90% of those invocations in this audit log if that were to happen by default.
Okay, so it definitely sounds like there could be multiple use cases with RBD as well.
Yeah, that's good. That's good to know, and probably should go into the tracker and worth moving the feature forward.
Definitely. Does anybody from RGW have any kind of similar thoughts on the way this could be used as an alternate, encapsulate more use cases? Or it doesn't have to be RGW, just anybody else.
I don't know. Would we want to potentially do something in RDW where we log changes to zone groups and that sort of thing? That's one thing that I can think of.
Makes sense.
In general, I do think it would be cool to have just a log of all of the Rados GW admin commands and their arguments that have run.
Great. Yeah, if anybody else wants to add, I think we should tracker with some of these findings, just so we can kind of streamline the end goal of the feature request. But all this sounds great. And Patrick and Venki both couldn't make it to the call, but they'll be watching this recording later, so they'll have all these suggestions that you guys made. Any concluding thoughts on the topic? All right, probably for the best since Prashant had a time limit. So thanks Prashant and everybody else who contributed for that topic. The next one on our list, see deduplication improvements, and there's an attached Etherpad. Who would like to lead that topic? I think Sam or Gabby.
Sorry, I was finding the mute
Screen
button.
so everybody can see the.
Can you hear me?
Yeah.
Okay.
I'm going to share my screen on the Etherpad.
Oh, great. Thanks. So broadly speaking, there is an existing deduplication implementation that Myungwon and some others contributed. It's a good start, but we are missing some things if we want to turn it into a general purpose deduplication solution. And the biggest single problem is that we can't afford to store very small chunks as individual Rados objects. There are a few reasons, but the biggest single one is that you can't store a 4 kilobyte EC object. I'll let you do the math on that one. The shards would end up being very, very small, and it would be quite inefficient. So we have a mismatch between the chunk sizes we would like to dedupe and the size of the object we would like to store in the backing pool, which would be big, 15 megabytes or something. Ideally, we would even like to store it with quite a large stripe size so that any particular chunk gets read from a single shard instead of all of them. So this calls strongly for packing little chunks into big pack objects. There are a few different ways to do this. One of them is we could do this within the placement group, but the problem is that that would not give us any freedom as to which chunks go into which pack objects. This brings us to the second problem with the current implementation, because chunks are, each chunk is an independent object. If you get a 4 megabyte object with a string of 8 kilobyte chunks, all of which are highly duplicated, you will end up doing 512 random reads instead of the 4 megabyte sequential read you meant to do. And they won't be from the same OSD either. They'll be spread randomly throughout the target pool. So we want to add an additional assumption as well. And hopefully data we collect will bear this out. The assumption is basically that when you see an object with a contiguous string of highly referenced chunks, it's likely that those chunks will be referenced in the same order together on other objects as well, which is to say that they're actually a much bigger chunk rather than a bunch of little 8 kilobyte chunks. So we can solve both of our problems by, when we're deduplicating the chunks in a particular object, we just make a point of putting them into the same pack object in the backing pool. It's not perfect. They could be torn across 2 pack objects, for instance, but it will still greatly reduce the number of reads that need to happen. And I think we can do this without any additional heuristic information, as any subsequent objects with these chunks will already find that they're in this pack object together. Let's see. The main challenge here is that doing it this way, it discards the primary piece of simplicity that the current implementation has, which is that the primary advantage that the current implementation has, which is that we don't need any kind of an indirection. The chunks name in the target pool also is how we find them. But with this implementation, we'll be free to put them into potentially any pack object. So we need some way of finding them afterwards during the dedupe process. So that means we're going to need some kind of an index relating chunk hashes to backing pack objects. This this is very much TBD. We haven't done much work on this part yet, but we can certainly talk about some characteristics this is going to need to have. There are 2 mutators. There's the background dedupe processes themselves. Every time we dedupe a chunk, it needs to go into this index, and garbage collection, which I'll get to later. And it won't be just one dedupe process. In general, if we want the space usage of a cluster to remain constant under mutation, we need the dedupe rate to be linear in the overall mutation or data creation rate. This means we're going to need potentially a number of dedupe processes linear in the overall cluster size. So the index is going to need to be able to tolerate and scale well to a potentially significant number of mutators. The mutators we can expect to mutate randomly across the index, although there's some ways to avoid that. If we instead partition the background processes using subportions of the hash space, we could get some locality that way. So we'll see about that. So garbage collection is the other half. The current design keeps ref counts on each backing object in the dedupe tier. That won't work so good here because we definitely don't want to be doing random IO to an erasure coded pool. If we, for instance, tried to put the ref count for each stored object into the OMAP or something, the OMAP, even if it were supported in erasure coding, which currently it is not, would have to be replicated across all of the shards. It would be quite expensive. So we probably want to put the information for garbage collection into the chunk index as well. So it will also need to absorb that mutation. And broadly speaking, the two strategies there are ref counts and a sort of a mark sweep approach. Ref counts require IO into the chunk index, linear in the number of changes to ref counts throughout the entire metadata pool. But by contrast, mark sweep requires for each sweep a number of mutations equal to the number of live hashes. And of course, a read across the entire metadata pool. So we'll have to evaluate which one of those is likely to be the better strategy. Anyway, that's my thoughts so far. Gabby, I think you actually had a comment about the assumption about, are you on here?
Yes, I am.
So you're objecting to the idea that we need, that simply, so the idea isn't that we're going to make any effort to pack related chunks. It's just that when we see a chunk reach the, when our deduplication heuristic says that a chunk is worth deduplicating, if we see a lot of those on an object, we're naturally going to put them into the same pack object because the dedupe processes are going to go one object at a time. We don't have to do any extra work.
Yeah, I understand this, but if let's think about the first object that you scan. The first object, of course, going to have 0 matches because it's the first. And then
yes, that's right.
You keep adding object, slowly you'd start to see a deduplication candidate maturing until you decide to assign them. Actually, I need to add something for the benefit of the audience. The decision seems to be that we're not going to dedupe each and every chunk, only chunk that are the number of reference exceeds some threshold, which, I don't know, 3, 4, 5, 6, 7, because there is an extra cost associated with accessing data indirectly by the dedupe process. So we don't want to pay it unless it's going to give us some meaningful benefit, meaning more than n duplications.
Yeah, so Gabby, we can avoid this problem. So what you're getting at is eventually we get to the first object with the string of chunks, but not all of the chunks register as being good candidates.
Yes.
Some are just below, some are just above. So we can make the heuristic fuzzy, where if we see a string like that, the more chunks we've deduped, or the more chunks we identify as new dedupe candidates, the more willing we are to dedupe the rest. That'll make it more probable that we capture the whole string in the first object, and we can do it entirely with local information. And that's going to be our strategy. We're not going to attempt to build any kind of further global indexing or structures here to make this process better. All it has to be is better than nothing at this stage.
So
right now, the nothing
option
strategy.
Just bear with me for a second. Another option is just to dedupe to whenever positions without worrying about relations between chunks. And once the dedupe stabilize, we could run a background defrag process going from the cache from the object perspective and saying, oh, this object are deduped, sorry, these chunks are deduped in the unrelated position. Let's relocate them all into another data tier object. Sorry, I take it back. It's impossible. No. Sorry, I take it back.
Yeah, it's not super tractable. If we find a clever way to do that, I think that's a great version 2 thing to discuss. For now, though, as long as we, with a decently high probability, tend to cluster objects more often than we don't, I think we'll be doing fairly well. Because remember, the situation we have now is that they will definitely never be in the same place. So if we get from 512 reads to like 4 reads, we've done really, really well, I think. Does that make sense?
Yeah, sure.
And we can definitely improve this later. That's the other major advantage of accepting the pain of having to create this intermediate index allows us later to a great deal of freedom. We can start adding more local information that allows us to make better choices. We can indeed add a background process that tries to relocate them to be close together. We can do interesting things if we choose to. And that'll be easier once we have an existing implementation we can measure against. We can also make it configurable. Different workloads may have different requirements here. workloads with high mutation rates are likely to favor different heuristics than workloads with a lot of objects that tend to get written once and not overwritten with a long lifetime. Any workload with a lot of objects with a long lifetime will favor strategies that have background processes to improve efficiency, since they'll be around for a long time to benefit from it.
Now, everything that you described is kind of the process in which we create that index is kind of orthogonal to how the infrastructure that we have already that you do, right? Because you can create all of that on top of what we already have, right?
In part, yeah, yes. I mean, the data structure and the object info might change just to make it smaller, but other than that, yes, it's pretty much the same idea.
So why don't we just go on with what we have now and say, let's have, I don't know, instead of a 4K chunks, let's have 128K chunks as a, as a first implementation iteration where we don't have the issue. It's not going to be as efficient, but at least we're going to have something to start working with.
It wouldn't, 128K probably won't do the job. It'll have to be more like a megabyte, I think, to make it efficient to erase your code. But yes, that is a viable option. I don't think you're going to get a workload with dedupe opportunities that big, though we are also in parallel trying to look for opportunity. I think Gabby's working on a tool that will scan Rados clusters and output some digested information. And if that digested information tells us that indeed with a 1 megabyte chunk size you can get reasonable dedupe ratios, then yeah, that would be a pretty strong argument for going with an initial version.
Right, because everything here is about,
smaller chunk sizes than 1 megabyte, yes.
No, that's not right. Had in mind. Like, we already have the infrastructure to do that. It's just like, how do you create those, reindex or reposition, repoint the objects, right, into, so whether you create like one big object that has a lot of chunks in it, or whether every object Redis object is a chunk, all of that is orthogonal to the dedupe infrastructure we already have working.
I mean, it will significantly affect the way the background processes work, but yeah, the metadata in the OSD doesn't care. That's true. It's a strength of the approach, I think.
Yeah, so my suggestion is to start with something that we can show working now, and improve on that, like iterate on that.
Yeah, I mean, it's an important point that this has contributed quite a few years ago, and there's published science on it. It would be desirable to figure out where it's not complete and possibly complete it and do empirical work, measurement of it, building on what's been done.
Yes, like I said, one of the other work streams is coming up with a tool to measure existing clusters to find out whether larger chunk sizes are going to work. Unfortunately, whether it works or not isn't a property of the implementation. It's a property of the workloads we expect to apply it to.
I don't really quite follow. I don't quite follow. I mean, I understand having additional measurement based on duplicability is useful in itself. But software engineering takes time, and risky new projects like distributed indexing take time and have a lot, have a lengthy development cycle. Whereas there's work that's been percolating and worked on for something like 6-7 years. Maybe more.
Okay. Do you have a specific test you'd like us to do on the existing implementation?
I'd like to see an analysis of what's required to complete it, and whether we could operationalize it in maybe a specific test. We bring it? Could we make it part of our continuous integration? Could we make it part of?
There's a toothology test for it already, but yes, that does need to be improved. That's one of the work streams that'll be happening also.
mean, are there other workloads wherein we think where it might be appropriate to use, and if so, how might we invite users to feel comfortable using it?
Yes, that's my
all.
my point. Whether or not it is worth using depends entirely on whether there is sufficient dedupe ratio available in the data set stored at the chunk sizes this implementation is capable of storing. There are no other, like, there are implementation factors to be sure, but the biggest one is the workload. Like, if there simply is no dedupe ratio, then there's no point in enabling it.
I read the entire TID paper, and I'm not going to inject myself into every dimension of it, but it feels like they did some of that work. So maybe we can take the workloads that for which the authors proposed its utility, and see if there are folks already using it in the wild, or if there are folks that have not been using it in the wild because they don't think the implementation is ready to go.
Okay, that's good feedback.
I think long goal for this estimation tool, if we can make it really lightweight, customer would have more incentive to use it. At the moment, the tools that we have in mind is relatively expensive in terms of CPU, I/O, and memory. So only customer really trying to get into dedupe, we're going to use it. But I think eventually we need to build a tool which is much lighter to give them more motivation to give it a shot.
Specifically, you want to avoid doing object reads. You want to use existing CRC data stored in BlueStore. Yes.
For example, that's if we want to address fixed blocks.
I honestly don't think it makes any difference. I think if you run the tools with some parallelism and some throttling, you can crawl the cluster in a few days on pretty much any size cluster, and that's going to be enough. I don't think it's going to disrupt anyone's workflow. And the advantage of doing actual reads is that we don't have to re-architect the entire interior of the OSD in order to support this tool. We will need to anyway, because one of the things we want to get from community clusters is detailed information from the inside of BlueStore for the benefit of BlueStore development. And the same will be true of CStore in the future. But I'm not sure it makes much of a difference for dedupe.
Mm-hmm.
And given the choice between answering a question that we can't answer with BlueStore and answering it, by doing an object read, I'm always going to choose to do the object read. I'd rather have the answer to the question.
So at the moment, is this kind of in the even before proof of concept stage? And when do you guys see these improvements or is there like a planned timeline yet for it?
So the next step will be coming up with a specific concrete design for the chunk index and garbage collection strategies. Once we have that, we'll post it to Ceph Devel, and then we expect this to take like a year to develop.
Okay, cool.
We also need to decide where to run this process. So there's a few options. One option is to have an external machines doing that. And I think a more realistic option is to run this as a function or an application on the storage nodes. The assumption is that customers are not going to install nodes just for the benefit of doing the deduplication.
However we do it, it'll be a separate process. It will not be co-located with the OSD daemon because the data affinity is wrong. So from our point of view, where it gets run will be a property of individual cluster designs. We'll give Rook and Ceph ADM the ability to run it probably, yes, on storage nodes, just as a default. But in large serious deployments, they probably will need dedicated machines for this because the more memory you dedicate to the fingerprinting process, the more accurate the dedupe selections will be.
The more efficient, not the more accurate. I mean, you could.
It's both. It's both. So you've been kind of assuming,
and everything would be understood.
hang on. You've been assuming that we'll be using the fingerprint index itself to do ref counting, but that's almost certainly not true. There are other, the traditional strategy is that you do so before you've chosen to dedupe a chunk, when you're estimating whether a chunk is likely to be a good candidate, as you see chunks, you put it into a much smaller in-memory representation that, for instance, only captures the first quarter of the hash or something. So it has a much, much higher, what do you call it, collision rate, but it takes up a quarter as much memory, so you can fit 4 times more in. And you also drop stuff off the end of that set if it doesn't seem like it's getting more copies. So then the reason for this is it lets you do the scan much, much faster and doesn't require you to be doing writes to durable storage. So if we use a strategy like that, the more memory you can dedicate it to it, the more accurate the process will be. And faster is also better. Like I said, the dedupe process needs to keep up with the foreground I/O rate. So that may be a factor as well. In any event, I don't think we're going to want to require it to be run on those storage nodes. We'll pick a reasonable default for Ceph, Idiom, and Rook, but for more complex clusters, they'll have the freedom to run it somewhere else if they need to. Does that seem reasonable to you, Gabby?
It does. I mean, I still expect customer to want the index to scale out with the cluster. So if the cluster used to be 16 machines and now you have 32 nodes, you need to scale. Everything should scale horizontally. So
yep, yeah.
installing
So like I said,
separate machine each time, I think it's unlikely to happen. But yeah, it's not a critical to the design. We could use it anywhere, but we need to define how much memory we can allocate. That's a critical thing to know. And memory should be proportional to the user data, of course.
Well, I mean, if it's scaling linearly, it shouldn't be, actually, right? Because we'll be partitioning the work among a proportionately larger number of processes. So that's a really important question that we'll get to soon, because it's gonna matter. For instance, if we find a way to if we set it up so that any particular background process only sees a subset of the overall chunks, then memory should be constant. You just scale the number of background processes. Does that make sense? In other words, let's say you have 16 background processes. If each one is responsible for 1/16 of the fingerprint space, then if you go from 16 to 32, you've doubled the size of the cluster, but you've also doubled the size. You've also doubled the number of background processes, and thus halved the proportion of fingerprint space they're responsible for.
How much you allocate to each one of them?
Yeah, I know. I'm saying if we do horizontal scaling like you're describing, it should be constant. It shouldn't vary with the size of the cluster.
Again, proportional to the data, everything you described, because when you scale that data horizontally, then you also scale the numbers. So everything scales proportional to the data size, to the user data size.
But the individual process memory space shouldn't, because you doubled the number of processes.
Yes, but
so
if you combine the memory used by all these individual processes, you actually
yes,
scale
that would be linear. I agree. Okay, got it.
And we need to decide how much memory is acceptable, because more memory means more efficient processing to do it faster. Less memory means you need to rely more on drives, and that's going to be hard, because the nature of this piece, everything is near uniform distribution because of the way hashing works. So all the tricks that we know how to use with drive databases, that you do caching and prefetching and such, not going to work with this, because we break it by using hashing. If you could fit everything in memory, or some subset of the table in memory, that would be best, but that's of course going to be expensive. So
I'm wondering if there are tricks we can play with Bloom filters that may actually be a way out of this problem, but I haven't pursued that thought very far. I agree, though.
Yeah, I mean, but even let's assume that we have some set of objects which are in reality duplicated, and that thinks, let's say 10% of your data chunks are replicated. So you need data structure to represent 10% of your data chunks. And the smaller the data chunk, of course, it's proportional. It's reverse proportions to the data size. So your data structure's memory consumption is proportional to the number of data chunks. If you increase the size of the data chunks, so you need less memory. That's another factor.
Yep, that's true. And there's another strategy I didn't mention before for finding ways of packing chunks close together. We could do scans at multiple chunk sizes. It would increase the amount of memory required, but it could decrease the amount of storage we need later if it causes us to instead store bigger chunks. Anyway, it's a thought. Probably makes the specific problem we're discussing now worse, though, because the in-memory data structures become bigger.
Yeah, and I
Although
try to do the memory calculation.
logarithmically
It's
bigger.
going to be enormous.
Yeah, so like I said, if you
rule of thumb saying 1 byte for 1 kilobyte of user data, or 1 gigabyte for 1 terabyte of user data, that's pretty extensive.
Yeah, that's quite a bit. We'll have to discuss that. The next step will probably be to game out several different ways of doing this and then evaluate the memory requirements and some other important properties
So of
and
course,
see what
you
seems
could
like the right trade-off.
use much less memory, but it's going to make you more dependent on disk, and that's going to hurt performance.
Yep.
If it's acceptable, I mean, it's a trade-off. More
Yep,
memory
so
will buy you better performance or quicker scanning.
Yep.
Radek, you wrote a comment about you like keeping dedupe separated from an OSD. Did you want to speak on that?
Well, it's
well, a while back.
at this moment I see at least two advantages of this design. First of all, we are keeping the isolation of complexity. There is OSD with its own budget, dedupe with its own. Perfect. But I also like this. I assume, well, I made an assumption that it will be based on basically standard Radius API. So if we change OSD implementation, it should work as well with Crimson.
Yep. We may change the dedupe APIs that exist. We'll basically change them to whatever they need to be for this to work well. But yeah, whatever it is, they'll be Liberados APIs or object classes.
I love that. For a second, I was a bit afraid, and that the dedupe could could be glued to internals of existing OSD. But clearly, that's not the case here.
No, you actually can't do the scan from the inside of the OSD for basically the reasons Gabby is describing. The data locality is backwards. We want to be able to locate similar chunks together in memory, not similar objects. So a per PG background process wouldn't do us any good. So
Yeah.
we're at least free of that one.
I don't know if you guys are looking for any more or any specific feedback, but one thing that came to mind just about thinking about when this is finally introduced, somebody mentioned that you want the users to feel comfortable using these dedupe improvements. And I think as you're going through this process to track down like how you're testing everything and the results that you gather. So if you get to the end of it, it might make sense to publish like a blog post on your the journey that led up to it, or just, you know, highlights that you want the users to know about the new improvements.
Sure, sounds good.
Well, this sounds really exciting. Was there any other comments that people had just hearing the implementation and all the testing efforts and everything? Or, oh, that's one thing I was going to say. Maybe I'd be interested to hear how you guys are. You touched on it a bit, but testing everything here and gathering results for the improvements.
Well, so far none of this exists, so there is no testing on it. The immediate goal, the very first thing, or one of the first things that's going to need to happen is a lot of these, a lot of the statements here are assumptions about common workload characteristics. That's unfortunately a basic property of deduplication. If the underlying workload has no duplicates in the first place, then it doesn't matter how efficient your deduplication process is. You won't find any. So step one is going to be, or one of the step ones is Gabby's going to work on a tool that allows us to extract a bunch of pieces of information from a Rados cluster, if anyone's willing to run it for us. Two of the important pieces of information are for several different dedupe chunk sizes, TBD, probably something like 8K, 64K, and 512K, and probably 1 megabyte. We want to know what is we want an estimate of the achievable dedupe ratio, and we want an estimate of the distribution of dedupe counts across chunk hashes. So basically, we want to know if we run a perfect dedupe process, how much space will we save? And two, are these duplicates concentrated on a relatively small number of chunks that are just duplicated a crazy number of times? Or is it more like half the chunks are duplicated once each? So those two dimensions will be, I think, are the biggest open questions I have. So once we have that tool, we'll probably publish a blog post explaining how to run it and how to give us the results. And once we have compiled information from that, if we get a reasonable amount of it, we'll probably put out another blog post so people can learn from what we have learned. As we get further forward in designing this, we will be, of course, adding appropriate technology tests because we need excellent test coverage of this stuff if it's going to be reliable. I would particularly like the index to be testable on its own. So that will be something that will need some thought, as that will be an important sort of load-bearing data structure. Gabby, do you have any thoughts on testing and validation?
Not yet. I mean, there's so much to think about because you do want to make sure that you. Sorry, there's one direction which is harder to test is that you didn't miss the duplication. The easiest part is to make sure that the data is accurate. So you do dedupe and then you read the data and so a very easy test would be if you write predictable data, meaning every object is having data which is a function of the object name and object offset, and then you run deduplications. Sorry, you need some predictable data and you do deduplication and then you make sure that you still get the same data. That's an easier pass. The second pass is how you make sure that you deduped everything which was possible. What was the actual duplication and how much you got in reality? That's another thing to choose. I mean, you can probably do some, if you create some kind of random distribution with some predefined percentage of duplications, and then you run the duplication and you verify how much of this has been caught. But it's hard to say if it's bug or if it's just a random problem because the offset, if the offset are not proper and not aligned, you might miss them even if your algorithm is valid and you have no bugs. That's
if you generate the object, if you create the object generator well, I think we can guarantee that it'll hit the right things. Actually, this is something we can do with the current implementation. This doesn't even need to wait. So this, to Matt and Yehuda's point, is something we can start developing now. Those tests. Another test that it will be of some value to create is, well, not a test, but Scrub should probably validate either all or a random subset of the chunks during deep scrub. Make sure that they're really where they're supposed to be and that their contents are hashed to the correct thing. So that's a work item we probably want to do as well.
We should keep with the date on the cache tier. Every time we dedupe chunk, maybe you should keep on the cache tier some short hash of the data, not 16 byte or 24 byte, something shorter, maybe 4 byte, which is going to represent the data to make sure that, or to allow you to verify that the data is what you expect to be.
For validation purposes, I'm going to require that we keep the original hash. We have to be able to prove that data is correct.
That's going to be expensive.
I know it's expensive, but it's absolutely mandatory.
I would argue against that. I would say that maybe 32-bit estimate should be good enough, because you know that the data have been moved somewhere, but it just means that nobody overwrote the data.
Okay, we'll discuss it. If this turns out to be non-trivial in the overall metadata overhead, then maybe. If it turns out to be not a significant contributor to the overall overhead, though, it's probably better to keep it.
It's just expense. It's not harder to implement. Actually, it might be even easier.
Yeah, I know. No, that's what I'm saying. If the added expense is large compared to the overhead we're already committing to, then I'll consider your point. If it turns out to be relatively small, then I think we should keep it.
Because if we want to dedupe data which is on spinning drive, which might be a good case, and then we add metadata which is on SSD, in the end, we need to do the math if it's still worth all the effort.
Yep, I understand. We'll do the math and we'll see if it's worth it. You're correct, though. We could keep a small prefix of the hash and use that instead.
Maybe just a CRC, because there's a CRC anyway stored on.
It's a crypto hash. Why would you? I mean, we already have the hash, and it's a crypto hash, so any subset of it's good. Why not just use suffix?
Okay. So you should fold. You mean you fold the hash into something smaller?
I mean, you can actually just truncate it. It's a cryptographic hash, so it's uniform across its whole range. They're really, really good. All the bits are good on a cryptographic hash. Any other comments?
Thanks for the really comprehensive summary of everything going on. And yeah, it looks like a good start, concept, high-level concept, and looking forward to seeing all the improvements. Cool. If that's good for everybody, I think this is the last topic on the agenda, so we can wrap up. Thanks, CDM, everybody, and I'll see you guys next month.
That's good. Bye.
Thank you. Bye.
Everyone.